Egun on guztioi, buenos días a todos. Good morning, everybody, and welcome. Lehenik eta behin, mila esker guztioi, puntako zientzialarien eta ikasleen arteko topaketa hauetara etortzeagatik. Zientziarekin solasean topaketen 8. edizioa da aurtengoa, eta oso pozik gaude eta harro gaude zue guztiak hemen zaudetelako. I would especially like to welcome our invited scientists this morning, Professor Karplus, Professor Bell, and Professor Cohen. Thank you very much for coming. Como decía antes, esta es la 8ª edición de los Encuentros y esto no hubiera sido posible sin el apoyo de los patronos públicos y privados del Donostia International Physics Center. En este encuentro en particular queremos resaltar la colaboración de Telefónica, patrono del DIPC. Telefónica patrocina los premios a la pregunta más innovadora, más ingeniosa, más imaginativa, creativa e interesante en estos encuentros. Y a lo largo de la sesión de esta mañana iremos conociendo quiénes han sido los ganadores de este pequeño concurso que realizamos dentro de los encuentros. Javier Benito, director de Telefónica Euskadi, está hoy con nosotros y quiero invitarle a decirnos unas palabras.
Bueno, egun on guztioi, consejera, rector, Pedro, Martin, Claude, Jocelyn y futuros investigadores, eskerrik asko etortxagatik. Hoy es un día bonito para Telefónica, del que estamos orgullosos, porque estar hoy aquí en Bizkaia, en Bilbao, en Euskadi, para un evento de la ciencia en el que somos patronos del Donostia International Physics Center, la verdad es que nos sentimos pues, todos los días orgullosos. En Telefónica en Telefónica utilizamos la ciencia para superarnos y evolucionar cada día. Temas como la fibra óptica de hoy, que es un tema normal para nosotros, pues hace unos años eran temas que se analizaban en los laboratorios y pues ahora mismo podemos estar con temas como el 5G, etc. A vosotros no sonarán raros pues temas que hace poco utilizábamos en nuestros laboratorios de Telefónica I+D, como Industria 4.0, inteligencia artificial, sistemas ciberfísicos, que supongo que alguno de vosotros el día de mañana tendréis responsabilidades en muchos de estos temas. En Telefónica la ciencia la tenemos muy interiorizada, no solo en Telefónica I+D o en nuestra startup, en nuestra aceleradora de startups Guaira, sino en un programa que tenemos además aquí en Euskadi de Telefónica Open Future, en el que tratamos de dinamizar, digitalizar y desarrollar la sociedad, porque entendemos que una sociedad desarrollada es bueno para todos. Para que os hagáis una idea, en este 2016 hemos estado apoyando proyectos sociales a través del programa Think. Con Fundación Telefónica estamos dando cursos de programación para jóvenes de unos 25 años para ayudarles en la inserción laboral. O hemos creado en Euskadi también 6 lanzaderas de empleo para ayudar a insertar laboralmente a más de 400 personas. Además, con Bizkaia tenemos un programa de Bizkaia Open Future en el que estamos juntando empresas, startups y talento emprendedor para generar empleo y riqueza en Euskadi, y yo creo que el Donostia International Physics Center es el punto de nuestra colaboración de la física donde lo llevamos al máximo extremo. Bueno, no quiero hablar hoy más de nuestros productos y servicios, hoy hemos venido aquí a aprender todos y eskerrik asko etortxagatik.
Eskerrik asko. Jarraian, Euskal Herriko Unibertsitateari ere eskerrak eman nahi dizkiot, gaur gainera bere etxean hartu gaituelako berriz ere, eta horretarako gurekin Euskal Herriko Unibertsitateko errektore Iñaki Goirizelaia daukagu, eta errektore jauna zurea da hitza.
Sailburua, DIPC-ko presidente jauna, Telefonika Euskadiko zuzendaria eta ikasleak eta lagunak. Egunon, good morning. And my warmest welcome to this gathering. For the University of the Basque Country, collaborating on this initiative with the Donostia International Physics Center is a source of special satisfaction. It is not our first collaboration, and it won't be the last. As Professor Echenique often reminds us, the DIPC was born from the University of the Basque Country, and many of its researchers belong to our university. We are really proud of it. This is something that will be improving in the time. The DIPC and the university walk down the same pathway and with a shared goal. So we are very pleased about this as University of the Basque Country. It is also gratifying to have researchers among us from like Jocelyn or Claude Cohen and Martin Karplus. It is a privilege and a great opportunity to be able to listen to their views. So on behalf of the university, I want to thank them for being with us today. Egunon, eta ongi etorri ikasle eta irakasle guztioi, eskerrik asko Euskal Herriko Unibertsitatera, Bizkaia areto honetara etorri zanagatik. Gaur saio berezi bat egiteko aukera daukagu. 3 zientzialari handi entzuteko aukera paraigabea. Sorte handia da zientzialariok gurean izatea. Eta hitzaldiak entzunez ezik, galderak egiteko aukera ere izango duzue. Era berean, interesgarria izango da eta zuen galdera horiek entzutea. Zientzia ez da bitzikeria gu gaindik urrun dagoen zerbait. Aitzitik, zientzia oso gertu daukagu. Zientziak inguruan ditugun gauzak azaltzen ditu, bai eta gure izaera eta jokabidea ere. Eta esan behar dut, amets bat daukadala. Hori politikari batek esan zuen bere garaian, Estatu Batuetan, esan zuen, I have a dream. Bueno, nik amets bat daukat. Eta hori ikusten zaituet, ikusten dut etorkizuna, eta hemen passion for knowledge, niretzat, etorkizun hurbilean, gustatuko litzaidake zuetariko baten batek sari Nobela irabaztea. Eta horretarako, kemena, ilusioa, gogoa, kreatibitatea, eta batez bere maitatu behar duzue zientzia. Merezi du eta, ia asmatzen dugun, ia ez dakit, 30 urte barru, sorte hori daukagun, eta ospatzen dugu Euskadin, sari Nobela irabazi duen pertsona bat daukagulako, eta agian, zuetariko baten batek lortuko du hori, ia amets hori egia bihurtzen dan. Quiero agradecer muy sinceramente al Donostia International Physics Center y a su presidente por organizar esta iniciativa y también a Telefónica Euskadi por apoyarla y, como no, al gobierno vasco. Y sobre todo, os invito a que lo paséis bien, a que disfrutéis, a que salgáis de aquí con ilusión y con ganas de conseguir un premio Nobel. Eskerrik asko.
Eskerrik asko. Eta topaketa hauek, hasieratik DIPC-ren patronoa den Eusko Jaurlaritzaren babesa izan dute. Horregatik, gaur asko poztu gaitu gurekin Eusko Jaurlaritzako hizkuntza politika eta kultura sailburua gurekin egotea. Kristina Uriarte, mesedez, zurea da hitza.
Pedro Miguel Echenique jauna, errektore jauna, Euskadiko Telefonikako zuzendaria, Martin Karplus jauna, Jocelyn anderea eta Claude Cohen-Tannoudji jauna, irakasleok, ikasleok, jaun-andreok, ongi etorri Passion for Knowledge barruan antolatutako topaketa honetara. Ongi etorri zientziaren solasean topaketara. Ezer baino lehen, Euskadira etorri diren gonbidatuak agurtu nahi ditut. I would like to thank our guests for joining us to this magnificent cultural and scientific event held in the Basque Country. Thanks to Professor Karplus from Harvard University. Thanks to Professor Bell from University of Oxford. And thanks to Professor Cohen from École Normale Supérieure de France. Y muy especialmente gracias a Donostia International Physics Center y en particular al profesor Echenique por su dedicación desinteresada a la realización de Passion for Knowledge por tercera vez, así como por organizar y moderar estos encuentros una vez más, y ya van 8. Y tras esta felicitación, quiero dar las gracias al profesorado que acompañáis aquí, a todos los chicos y chicas aquí presentes. Nuestra sociedad no avanzaría sin vuestra labor, así que quiero aprovechar este momento para reconocer vuestra aportación al desarrollo de Euskadi. Eskerrik asko benetan, nire ustez hori delako benetako bidea. Zuek, irakasleak, gizarte honez etorkizuneko zutaben ardura duzue. Gure seme-alaben ibilbide akademikoren ardura. Biharetzi herri hau bultzatu beharko dutenen formakuntza hain zuzen ere. Eta hori horrela izan da ere, askotan ez duzue gizartearen eta erakunden errekonozimendurik. Y a los estudiantes, a los alumnos y alumnas que estáis aquí, mila esker, benetan mila esker eta zorionak. Y digo enhorabuena porque sin duda habéis hecho una buena elección en acudir a este encuentro. Sabed que no es sencillo ni habitual tener la oportunidad de asistir a conferencias de la mano de científicos del nivel que hoy nos acompaña. Así que, como digo, habéis elegido bien. Hoy habéis elegido atender a vuestra pasión por conocer, vuestra pasión por saber, vuestra pasión por la ciencia y vuestra pasión por la cultura. No es poco. Guztiok oroitzen gara gure irakasleez eskolako ikasketa urteak eta han egindako aleginak atzera uzten ditugunean. Eta gainera, irakasle horietako askoren oroitzapen ona gelditzen zaigu. Eskolan bizi izandako une berezi horien oroitzapen ona gordetzen ez duenik ez da izango. Gauzak borobilatera zitzaizkigun egun ura, gustoko ikasgaia edo atseginean ematen zigun irakasle ura, bai, ziur naiz urteak igar ondoren, gaurko hau zuen oroitzapenean geldituko den egun bat ahaztezin horietarako bat izango dela. Y lo digo convencida. Es un lujo escuchar y aprender ciencia de la mano de científicos excepcionales y es un lujo que sus consejos puedan ayudaros a tomar decisiones sobre nuestro futuro y eso sin duda lo vais a recordar en los próximos años. Pero además, si alguien en la sala pensaba que se iba a librar, debéis saber que no habéis venido simplemente a pasar el rato, también vais a trabajar. El DIP ha organizado el encuentro de forma que vosotros y vosotras también seáis protagonistas. Guztiok erabaki garrantzitsu bat hartu beharko duzue laster. Zein karrera aukeratu, norantz bideratu zuen ikasketak, seguru nago zuetariko batzuk argi izango duzuela, baina beste batzuk, ordea, oraindik ere zalantzak izango dituzuela. Bazuoi, guztioi, mezu bat luzatu nahi dizuet. Zientzia ikasketek pena merezi dute, abentura bat da. Sé que muchos estáis decidiendo qué carrera universitaria estudiar una vez que acabéis los estudios en la escuela o en la ikastola. Pues bien, voy a lanzaros un mensaje claro y contundente. La formación científica os hará aún mejores. Se oye a menudo que una carrera científica exige esfuerzo, muchas horas de trabajo para entender conceptos y fenómenos complejos, enfrentarse a problemas difíciles y muchas más cosas. No es un camino fácil, no, pero merece la pena. Con ilusión y perseverancia. Se transforma la visión de la naturaleza, de lo que nos rodea y ocurre alrededor nuestro. Se desarrolla el espíritu crítico, una capacidad de observación y de admiración ante todo lo que nos rodea. Aprendemos a mirar el mundo de otra manera. La ciencia es análisis, es método, es rigor, es precisión, es lógica, sí, pero también es intuición, imaginación, creatividad. Una formación científica permite, entre otras cosas, extraer lo fundamental de problemas complejos, para que a través del conocimiento se busquen y se aporten soluciones a veces inimaginables. En palabras de Pedro Miguel Echenique, la ciencia es el arte de la imaginación. Pero creo que el ingrediente más importante es el amor por lo que se hace. Pues bien, hoy vais a poder practicar esa forma de trabajar. Eso es lo que vais a tener que hacer hoy tras escuchar a estas personas excepcionales. Tenéis nada más ni nada menos que extraer de toda la información que vais a recibir aquella que realmente os sirva para tomar vuestra decisión. Es decir, antes incluso de ser científicos, vais a tener que tomar la decisión de serlo aplicando su método como lo harían ellos y ellas. Badu zientziak abentura puntu bat. Eta hementxe dugu horren adibide, garbia. Hemen, gurekin, dauden gonbidatuek asko dakite horretaz. Beraien ibilbideetan, imaginazioa erabili behar izan dute, arazo berri aurrera egiteko, balioz duten formulak baztertu eta bide berriak bilatzeko, emaitza ona edo txarra izango den jakin gabe. Lo que mueve al científico es la curiosidad, una intensa y abrumadora curiosidad. Una curiosidad por saber y por explicar fenómenos hasta entonces inexplicables. En esencia, un científico es una persona que no se conforma y que busca soluciones y explicaciones más allá de lo conocido. Hemen, ikusten zaituztet, zientziaren enbasadore diren zientzialari hauei entzuteko irrikaz. Zerbait galdetzera ausartuko zareten zalantzarekin, ez lotxatu, animatu zaitezte. Zuek hemen ikusita, nire baikortasunak gorantz egiten du. Necesitamos personas con espíritu crítico y con práctica en la formación científica, técnica y humanista, que estén bien preparadas para abordar la resolución de problemas complejos y desempeñar tareas de alta complejidad. En resumen, os necesitamos. Elkarren beharra dugu, zuek gure bultzada gabe oso zail izango zenukete, baina zuen ilusioa eta esfortzu gabe gu hemen soberan egongo ginateke. Gaur, oso aukera polita duzue, zientziaren munduan erreferente diren zientzialaren eskutik zientziaz gozatzeko. Seguru nago, hemendik urte batzuetara, zuetariko batzuk, errektorek esan du bezala, honelako topaketaren batean hemen goian egongo zaretela. Zuek izango zaretela islariak, adituak, beste ikasle batzuen aurrean. Etorkizuna zuena da. Eskerrik asko.
Mila esker. Bueno, dakizuen bezala, gaurko ekitaldia bi ataletan banatua egongo da. Lehenengo, gure gonbidatuen azalpenak entzun ahal izango ditugu, beraiek beraien buruaren eta beraien bizitzaren aurkezpen labur bat egingo dute, eta ondoren galderekin hasiko gara. Albaldin badegu, galdera batzuk egingo ditugu kafea eta hamaiketako egin aurretik 11:30, eta luzatuko baliz, kafearen ostean hasiko gera galderekin. Baina, nik uste dut denbora emango digula lehenengo pixka bat hasteko zuen galderak entzuten. Horretarako zerrenda bat badaukazu eta gero esplikatuko dizuet nola funtzionatuko duen. Baina orain besterik gabe, gure gonbidatuak estenatokira igotzeko eskatuko diet. Profesor Karplus, Profesor Cohen and Profesor Bell, as well as Profesor Echenique, please.
Egunon, nire lehenengo hitzak eskerrak emateko izango dira. Eskerrik asko ikaslei eta eskerrik asko irakaslei gurekin egoteagatik. Benetan, pozgarria da hau beteta ikustea eta eskertzen dizuet bihotzez. un agradecimiento especial a los profesores y a los alumnos que nos acompañáis hoy. Y, como no, many thanks to our speakers who have come from a long place, and even Claude, after quite a big accident, but he didn't want to miss you, and he has come because he loves to stay with young students and has been not only a great scientist, as a great teacher, as Martin, as Jocelyn. Jocelyn was asking me about how many girls and boys. I think the girls are majority here. In any case, the girls are going to be majority in the Basque Country very soon, very soon. So, eskerrik asko guzti. Ahora le daremos la palabra y ellos, no sé cómo está funcionando la traducción. Translation is working. No, you don't follow the translation.
You'll have to translate for me.
Okay, then I say most of it.
Another thing, can they turn down the lights a little bit? I would like to see the students.
Yeah, okay. Podemos bajar las luces un poco.
Yeah, whatever.
But maybe it's being televised, no? Okay?
I can't wear all these things.
Yeah, it's good. Anyway. Okay, now we have 5 minutes, more or less 5 minutes talk about your lives, and after we will begin with the questions. So, well, 5, 10, whatever, but not 35. So please, you begin. Yes, Professor Karplus.
Well, a very good friend of mine once wrote that children, when they're little, are curious about everything. And then as they go to school, they're taught as if the world is completely understood. And so they lose their interest in the world and in science. Maybe that's not true in the schools here in the Basque Country, but it's schools all over the world. And scientists are the people who continue to be like children and still find the world fascinating. And in a way, that's my own story. I was born in Austria in 1930, and when the Nazis came in, you of course had similar problems in Basque Country and Spain. I was lucky enough to be able to escape to the United States and have lived there most of my life, having come back to Europe, to Strasbourg, to also work there. And science has continued to fascinate me, and as I said, like a little child, I continue to wonder about the world and try to understand it. And I hope that some of this will carry over to you as you grow up and learn about the world. Thank you.
Okay, I think now Professor Cohen or Claude, the computer.
There you go.
Thank you. Thank you. First, before starting, I would like to thank my friend Pedro for inviting me here. I'm always happy to be with him in the Basque Country. I attended already a very interesting meeting, 3 or 4. And unfortunately, I had an accident 4 days ago, and I was afraid not to be able to come. This is why I wear some sunglasses. Hopefully, I was able to come. So perhaps for introducing myself, I've made a few slides, which I would like now to show you. No?
The slide, what, as transparent, yes. Always, una broma mientras, I think every time we try technology fails, I remember, I used to think that science is what a father teaches the daughter, and technology what the daughter teaches the father. So we have why it's not working, maybe then we could solve it quickly. Anyway, what we do, Lord, if you think, while they solve that, we give the word.
Okay.
Jocelyn, you take over. Flexibility.
Okay,
It's coming.
how's that work now? Okay, So, okay, now I see. So I just a very brief description of my itinerary. You know, I was born in Algeria when Algeria was part of France, and I did all my high school studies in Algiers, which was a very great city. And this is a picture of a class photo. I think, let me take my pointer. I am here. Then I was admitted at École Normale Supérieure in Paris, which is a high school for preparing for teaching and research. And then I met my two thesis supervisors, Alfred Kassler and Jean Brossel, who were outstanding physicists. And I did my PhD there, and I was also, I show this picture because I was following lectures at that time at the universities where no quantum mechanics course at that time. But in Saclay, Albert Messier, you probably know Albert Messier because he wrote two famous quantum mechanics books, and you see here, a long time after he wrote the book, I'm discussing with him. Then I did a PhD work in 1962, and I was appointed at the University of Paris, and I taught quantum mechanics during 10 years, and during that time we wrote two books, two-volume books, Quantum Mechanics, Mécanique Quantique, with Bernard Dieu and Franck Laloy. And this book has been translated in French, in English, excuse me, and now, 2 years ago, they were also translated in Chinese. We received the books. And in fact, we are, with Franck Laloy, trying to write a third volume to complete. Then, after that time, Alfred Kassler won the Nobel Prize in Physics in 1966. And I show you a picture when he came back from Stockholm. All the lab was on the entrance of the lab, and we took a picture. And I would like to show you this picture. Alfred Kassler is here. Jean Brossel is here. I am here. And I was starting to have my group, and my first two PhD students were Nicole Ostrowski and Serge Haroche. And you know probably that Serge Haroche got the Nobel Prize in 2012. So I think this picture is moving for me because you see three generations of physicists, Kassler, myself, and Serge Haroche, who won the Nobel Prize. So this shows that the personality of Kassler was outstanding for stimulating young people to do research, and he was able to create a fantastic atmosphere in the laboratory. And I think that science needs to have this atmosphere for progressing. Then after that, I was elected at the Collège de France in Paris. You know, Collège de France is something very strange. It's unique in the world. It's a place where you are elected by your colleagues in all disciplines. It's not science only, humanities and so on. But the important thing is that you have to give different lectures every year, which is quite demanding. And the people who come to attend this lecture don't get any degree. They just want to come to learn something new. And I remained there 30 years, and during 30 years I have to give lectures different every year. That was a lot of work, but very stimulating for learning new fields. And I just mentioned that these lecture notes are available, all the lecture notes are available at this website. So I think I will stop here, and then I continue to work, and I got the Nobel Prize in 1987, and I have a lot of people working with me, and the field, perhaps I will discuss it more in detail in my plenary lecture Friday, but that's now a very exciting field. So thank you for your attention.
En mi generación nosotros estudiábamos física cuántica con el Messiaen y todos se referían al Messiaen, pero todos mis estudiantes de doctorado no conocen el Messiaen. Ahora conocen Cohen. El Cohen es el Quijote de la física cuántica y todos los estudiantes la usan en estos momentos. Now, I was saying that in my generation, Messiaen was the book. I read the Messiaen. Read the first one more than the second one, but all my PhD students don't know the Messiaen. Now it's the Cohen. Cohen is the Molière of quantum physics.
Yeah, two of the concepts.
Yeah. Two also, yeah. But we said one, the Cohen.
We're very closely.
In Spanish he said El Cohen. So it's the book that everybody now uses as an outstanding book because he's an outstanding teacher. Jocelyn.
Thank you. I'm Jocelyn Bell Burnell. I was born in the north of Ireland, which is the British bit of Ireland, in 1943. I started my academic career by failing an important exam at age 11. So I should have become a hairdresser, or a secretary, or a cook, or a clerk. But my parents argued for me to stay in the academic stream, and so I went into the higher level of schooling. And then in the first week of school, higher school, a message went round the class. This afternoon, the boys to that room and the girls to that room. The boys were sent to the science laboratory, and the girls to the cookery room. No discussion, no choice. That was the way it was. So again, my parents had to ring up the head teacher and and next time the science class met, there were 3 girls and all the boys. And the teacher made us 3 girls sit right in front of him. Girls are dynamite, aren't they? I did very well in the physics exam. I came top of the class. Maybe the school learnt something. Girls can do physics. But it takes a long time to change society. So I think they did not learn very quickly. But I did well in the physics class. I did okay at chemistry. In biology, we drew flowers and we labeled the different bits of the flowers and we learnt the names. I thought, that's not science. So I have never liked biology because of that. As I went through high school, I was thinking, I will be a physicist, but what kind of physics will I do? And through reading my father's library books, particularly a book by Fred Hoyle, I discovered astronomy. I said, yeah, I will be an astronomer. And at this time, there were new astronomies like X-ray astronomy, radio astronomy starting. So I will be a radio astronomer. I did a physics bachelor's degree and then went to do a PhD in radio astronomy in Cambridge. And it was there that I discovered the pulsars, for which I did not get a Nobel Prize. After that, my path becomes very different from a man's path, because I got married and I had a child. And we moved house to different parts of the country frequently, so I moved from radio astronomy to gamma ray astronomy, one end of the spectrum to the other, and then to X-ray astronomy, and then to infrared astronomy, and then to millimeter wave astronomy. And I have done many kinds of jobs. I have been a researcher, yes, and a lecturer, yes. I've also been a tutor. I've been a lead really because all those things, because I'm a woman and my career has been a bit here, a bit there, a bit there, a bit there. But it's been very interesting and great fun. And I am now retired, I'm 73, and I'm still busy and I'm still having fun doing many, many things.
Thank you very much. Jarraian eta aurretik esan bezala deskantsuaren barkatu. Thank you very much. I don't know if you could hear me. Deskantsuaren aurretik esaten genuen bezala galderekin hasiko gera. Osea, hor poltsan jaso dituzuen zerrenda horiek ateratzen joan zaitezkete. Muy brevemente voy a antes de comenzar con las preguntas, voy a preparar la pantalla. Listo. El listado que tenéis casi todos ya entre manos contiene las preguntas que nos habéis enviado a través de los profesores. Hemos recibido 3 preguntas por cada uno de los centros participantes, o un máximo de 3 preguntas por cada centro participante, y hemos tenido que hacer la mínima edición posible para bueno, primero filtrar las preguntas que están repetidas, de forma que cuando aquí las vayamos sorteando no nos salga una y otra vez la misma pregunta, porque sí que hay algunas que son recurrentes. Entonces, ahí hemos hecho un pequeño filtro y hemos editado también las preguntas compuestas por 2, 3 o 4 preguntas, porque bueno, hay veces que la segunda pregunta hace referencia a la primera, pero hay veces que no tanto. Entonces...
Habla un poco más alejada del
Perdón,
micrófono.
ay, perdón.
Porque el ruido del micrófono le impide a él entender la traducción, creemos. Igual esto no es una solución, pero para nuestra...
Así bien. Vale. Listo.
¿Se escucha ahora?
¿Se escucha mejor?
Now you listen better? Now? Close?
¿Regular?
No? Now better? Now you listen better?
¿Vale? A ver si se va escuchando mejor. ¿Sí? No, más alto.
El ruido del... No es culpa de nadie, es el ruido del micrófono. Ok, no worry.
Pequeña pausa técnica.
Continuamos. La pregunta aparecerá aquí.
Sí.
Aparecerá aquí. Venga, continuamos.
Vale. Hemos preparado un bombo virtual con todas las preguntas. Como sabéis, tenemos 3 tipos de preguntas: las preguntas biográficas, las científico-técnicas y las generales. Duan galdera horiek multzokatu egin ditugu eta 3 bombotan jarri ditugu. Errepikapenak pixka bat garbituta, baina beti ere kontuan izan dugu zentro bakoitzeko gutxienez galdera bat egotea gure bomboetan. Orduan denek daukazue galdera egiteko aukera edo probabilitate antzekoa. Horrela, ikusiko dugu, joango gera aukeratzen, galdera mota desberdinen artean saltatzen joango gera, eta bertan agertuko da zenbakia. Zenbakia agertzen denean, eskola ere ikusiko dugu pantailan, eta galdera ere pantailan ikusiko da, baina hala ere eskatuko dizuet galdera egiteko, galdera hori egin duen ikaslea altxatzeko mikrofono bat gerturatuko dizuete, eta galdera egiteko gure gaurko gonbidatuei. Bueno, beti dago urduritasun pixka bat, baina orain egingo ditugu lehenengo galderak eta gero ja ikusiko duzuen nola dena oso ondo pasatzen den. Ez eduki lotxa gehiegirik. Bueno, galdera biografiko batekin hasiko gera. Bagoaz. 57. galdera. Elkarrezi zentrotik, Bilbotik egin digute eta mesedez jar dadila gure lehenengo ikaslea zutik. Mikrofonoa gerturatzeko.
Antoni Geoxekin batera aurkitu bazenitun pulsar baten irratizen gerak zergatik ez zenuten biek irabazi Nobel saria, zer gertatu zen?
Thank you. I had to wait for the translation. Things are different these days, but when I was...
When I will translate the question to the decision maker. The question is, you found together with Tony Hughes, why didn't you both get the Nobel Prize? Now that's correct.
So today the Nobel Prize Committee does things differently, but way back then in 1970s, students were not people. Students were done there, and only the top man, and it always was a man, got the prize. That was just the way it was. It was not because I was a woman, it was because I was a student that I did not get it.
Well, I think there's a little more to that. I think it's partly because you were a woman, because there are several other women, like Rosalind Franklin, who made the X-ray studies which permitted Watson and Crick to determine the structure of DNA and show that Pauling, who didn't have these data, got it inside out. And then there's another woman who worked with Otto Hahn, Lisa Meitner, who's actually a distant cousin of mine, who should have gotten the Nobel Prize because Hahn was a chemist. Not, I'm a chemist, so I'm allowed to say that. But she was a physicist, and she was the one who actually understood what Hahn's measurements meant in terms of the fission of nuclei. So I think there is something about being a woman as well as being a student that played a role in those days.
Yes, but those women were not students. They were older women. The ones
That's true,
you
but they
mentioned.
still didn't get it.
Agreed, agreed.
Okay, yes, I had it. Thank you very much to Martin for pointing that out. There's also a fourth woman, Chu, which is involved.
Madam Wu.
Who was involved in the violation of the parity in interactions that also didn't get the Nobel Prize. Minor, Franklin, although Franklin probably will have not got it, but Franklin died before, no, the Nobel Prize, no? She died before. The Nobel Prize was 62.
I don't know.
Anyway, it is clear that women were not very well looked after and considered. But I'm sure after talks like the one Jocelyn gave in San Sebastian and listening to her today and in many other places, now nobody will have any doubt about that the women are going to lead the future. Anyway, next question.
Bigarren galderarekin goaz. 38. Alazne ikastetxeatik.
¿Es duro compatibilizar la vida familiar con la ciencia?
Is it hard to make it compatible, family life with science? So, you begin, Martin.
I think to a certain extent the answer is, am I being translated? Or, yeah.
Here.
is difficult. My wife says that all I do is science. I do science all the time. But nevertheless, we have a good life. And basically, when I'm working on science, I work on science. But then we take trips. And as you will, some of you will be able to see, I have a photographic exhibition here in San Sebastian, which was part of the life that we traveled together around. And also, like, I'm also a chef. I've cooked with Arzak, and at home I do the cooking. My wife washes the dishes. So we have many things that we do together that make, although you have to be a good scientist, there's no question that you have to work very, very hard, but you can make a life. And we have 3 children, 1 grandchild, and I think the family meets together in various parts of the world. So you can combine the two, but you have to make sure that you're thinking about it to actually make it work.
It's not always easy to combine science and family life, but I think it's important, you know, because the scientists in general have to work a lot to spend some time, day in the lab, weekend, vacation, writing books, preparing lectures. But I think it's very important to have a good harmony in the family. And my wife, who is here, Jacqueline, has always been supporting me. I remember that the first experiment where we got a very important signal when I was doing my PhD, we were together in the lab on the night of Christmas, because then most of the equipment was not running, so there was no noise, and we spent the night taking data. So you see, also when you have children, it's important that the children say that their father, their mother are very excited by science, and they are stimulated to do science. And our 2 children, Michel and Joel, are both now doing research in biology. So I think my answer is really important to have a good family support to do science.
Yes. For a lot of my working life, I was working part-time so as to be able to look after our son. And in the middle of the day, I would be driving home from work to go and get my son from school. And sometimes I had my best ideas then, my best scientific ideas, or I suddenly realized something that was true. So having a little bit of space in your life, if you are a scientist, is as important as working. So I would argue that work-life balance is important and helps the science, and that just being present in the laboratory but half asleep because you're exhausted is not so good.
Thank you. Bueno, jarraituko dugu, aldatuko dugu, pasako gera galdera zientifiko-tekniko den batetara. Ehun da hogeita 8. Miguel de Unamuno zentrotik. Anatzean.
Zergatik, pulsaretan soilik mantendu daiteke materia maila nuklearrean.
Why you can only keep going the pulsars with nuclear matter? Is that correct, the translation for the one who has done it?
Okay. star were much more massive, it would have such strong gravity that it would collapse to a black hole. And indeed, we suspect in some places the neutron star, with its gravity, has pulled more material down onto itself and has become so massive that it does collapse to a black hole. The neutron star or the pulsar is a result of a massive explosion of a big old star. And in the explosion, the core of the star shrinks to become one of these neutron stars or pulsars. And they have a great range of density. They are 10 kilometers radius, and as you go from the surface of the star to the center, the density goes up by 10 orders of magnitude. So huge range of density, huge range of physics. And to give a proper answer to that question, I would have to discuss each layer inside the neutron star. But broadly speaking, it's because there are neutrons around, and the neutrons are particles that we call fermions. They each need their own space, so they keep the star up. I think that's the best I can do at this level.
Beste bat. Guazen 156arekin. Colegio de Nuestra Señora de la Mercedeko ikasleren bat, mesedez.
In your opinion, what will be the most vital current in the study of universe in the coming years?
Astronomy is in a very exciting phase, and it's having big influence on physics. When I started in astronomy, we thought we understood 95% of the universe. We now know that we understand 4% of the universe. And the other 96% we do not yet understand. About a quarter of it is material we call dark matter, material that you cannot see, it's dark, but it provides gravity, and it's what holds galaxies together. The only thing we know about dark matter is that it cannot be made of the same stuff as this, and us, and our world. It cannot be neutrons and protons and electrons. It's something totally different. When we work out what that is, that will have a big effect on physics. And the other 70% is what we call dark energy. The universe is expanding. Initially, there was a big bang, big explosion. Universe expanded. It's still expanding. You would expect it to be slowing, but actually the expansion is getting faster. It is accelerating. And that's nonsense. How can it accelerate? It is. There must be something that we call dark energy pushing the galaxies, pushing space out. And at the moment we have really zero idea about what dark energy is. But it's clearly very important and very fundamental. And when we work out what that is, that will have changed physics again. So it will be your generation that works out what dark matter is, and maybe also what dark energy is, and causes at least one and maybe two major revolutions in physics in the coming 50 years, I judge.
When you say, well, now we realize that we know 4%, how can you be sure that in another 10 years you'll realize all of a sudden that this 4% was only 0.1%? How can you be sure that you already have such a full knowledge that there are only certain things that you have to learn and then you'll understand everything?
As you can see, everybody is a student here. So the student Karplus also has a question in spite of not being in the ballot, but we allow it. You also have a question? One moment. But then let me ask you a question before the answer, because everybody now, many people think that the most fascinating thing is the very big or the very small, but the complex and other, the nanotechnology, chemistry is also very, very interesting. In fact, Jean-Marie, your friend, said this 4% is only 4%, but it's the matter that matters. So what are the discoveries in your field and your field that you think they are going to be changing the universe? You have a question? Another question?
To ask to Jocelyn what she thinks about the discovery of gravitational waves. Would this discovery change the situation for dark energy and dark matter or not?
So perhaps answering Claude's question first. Maybe you remember in February or March this year a big announcement about the discovery of gravitational waves, gravitational radiation. That was a very big achievement which people had been working for 40 years, 40 years. It was not unexpected. It was good to have the confirmation, but there had already been indirect evidence, and it was predicted by Einstein. So in a sense, that discovery is tying finally together many, many things. To go back to your question, it's important in science never to believe you have all the answers. You must always have an open mind, because things can change hugely as our understanding of the universe has changed in our lifetime. So one of the problems with science at school is you are taught this is true, this is true, this is true, this is true. Maybe, maybe not. As you will learn more science, you perhaps come to see that it's important to hold these ideas provisionally. This is what we currently believe is true, but we must have an open mind and be prepared to change our minds and abandon those things that we thought were true in the face of new evidence.
So for you both, in your fields, because not only the very big is the important thing, the small, the complexity, for each of you, what do you think is going to be the greatest discovery of the future? And you, if you don't want to answer, don't answer.
Well, I'm not sure I'll be around for this greatest discovery in the future, but clearly one is beginning to understand the living systems at a more and more detailed level. Early on, living systems were just, the human body, a heart, a stomach, and so on. Now our understanding of living systems is going down to the detail that we know what it's made up of proteins, nucleic acids, and so on. And the very important near future, I won't predict the far future. People have said it's very easy to predict the past. It's a little bit more difficult to predict the future, really predict the future. But I think what is happening is that our understanding of how the molecules work together to give us cells that function, and the cells function together to give us organs, that's what's happening. And in biology and chemistry, I think we don't have quite the same sort of sudden increase in knowledge, that there's something brand new that's discovered. It's that our understanding evolves slowly, but it's getting to the stage now, and this is one of the projects about. You know that flu, influenza, you have to get vaccinated every year because it changes so rapidly. Well, we're working on a method to try to make a vaccine that's smarter than the flu virus and that is able to cover all the possibilities that the flu virus can assume over the next 10 years or so that you won't have to be vaccinated every year. I don't know whether this project will work, but I'm very excited about it, and I think this excitement is one thing that helps to keep you young.
A short answer about the future of the field.
In my field, there's also Greek mysteries. Quantum physics predicts what we call entangled states, or linear superposition of states. You know, there is the famous paradox of first explicited by Schrödinger, the Schrödinger cat, which can be in linear superposition of the cat which is alive and the cat which is dead. So you can have a superposition of two states where the particle is here and the same particle is at the same time here. That's very strange. And there are more and more experiments trying to investigate this kind of state. There are hopes to use this state for communication, even for a long-term perspective, to build a quantum computer, which would be much faster than the present computer. So I think science is always progressing by asking questions and trying to understand and to make more and more precise experiments to test the present theory. And if something disagrees, then you can have a revolution. And I think that science progresses by revolution. There have been many revolutions in the history of science. The relativistic revolution, which changed completely our concept of time and space, the quantum revolution, which changed completely our understanding of the microscopic world. And we can hope that would be the next revolution.
Okay. No penséis que estas cosas solo se estudian en Harvard o en Oxford. En el País Vasco hay grupos muy buenos de nivel mundial que se preocupan de estas últimas cuestiones. Aquí, por ejemplo, está Gonzalo Muga, profesor de la Universidad del País Vasco, que es uno de los grandes investigadores en este campo, y aquí que está en Bilbao, y que en el DIPC. O sea que estamos en la vanguardia, pequeños, pero tenemos nuestra gente en vanguardia. Siguiente, por favor.
Vale, hacemos la última pregunta y después vamos a ir a hacer la pausa del café. 129. galdera. Ategorrieta zentrotik.
Nola lortu zenuten Usar baten lehenengo irrati-seinalea?
I found that first signal by accident. I was being particularly careful and thorough because I had found myself in Cambridge almost by accident. Cambridge is a very famous university, and I had come from the edge of the United Kingdom, and they're all terribly clever in Cambridge, and I'm not so clever. I will have to work very, very hard. And even then, they may throw me out. So I was working very, very hard, and the first pulsar signal showed up as we were using long paper charts, and I had probably 300 meters of paper chart, and this signal occupied about half a centimeter. I was being so thorough that I noticed half a centimeter in 300 meters because it didn't make sense. I couldn't classify it. It was a puzzle. And when you train as a physicist, maybe when you train as any kind of scientist, your brain stores puzzles. Maybe you already noticed this. When you do exams at school, the things you understand, that's okay. The things you do not understand, and you have to learn this step, this step, this step, this step, this step, without understanding, those really trouble you. This was something that really troubled me, because I could not understand it. So that's how I noticed it. But it then took me a month to realize that it was pulses, and then it took us another month to be clear that it was not some fault of the equipment or interference or something else spurious. So it's quite a long process.
Jarraituko dugu bigarren zatiarekin, orain galderak egingo ditugu ordu batak eta laurden arte inguru horretan. Eta, bueno, lehenengo gauza egingo duguna, sorteoarekin jarraitu aurretik, izango da lehenengo sari bat banatzea. Zer iruditzen zaizue? Ondo, ez? Bueno, Telefónica ha seleccionado 3 preguntas como las más innovadoras, ingeniosas, imaginativas, creativas, interesantes u originales de entre las más de 170 preguntas recibidas en estos encuentros. Para hacer
la luz, por favor. Un poco.
Para hacer entrega del premio me gustaría pedir al señor Benito que suba aquí conmigo al escenario.
This is the first prize, the prize to a good question.
Aukeratutako lehenengo galdera, honako hau izan da. La primera pregunta seleccionada ha sido la número 69 del estudiante del Centro Ikasbide de Bilbao, Daniel García Cearra. Daniel, por favor, vamos a pedir que subas al escenario.
Oh, muy buena, very good question. Very good question.
Nuestra vida diaria está condicionada por las leyes de la física. ¿Alguna vez has soñado con cambiar alguna? ¿Cuál sería y por qué? Bueno, esta pregunta en realidad estaba dirigida a Claude Cohen en vez de a Denny, pero me sirve para todos.
Yo creo que para todos. Muy bien. So the question is, our daily life is conditioned, is governed by the laws of physics. Have you dreamed sometime of changing a law, one of the laws? Which will you change? Which law of physics will you change? If
for me, the question?
The question is for you, for everybody, but for you the first. Yeah.
No.
For you.
That's not the question.
Our life is governed by laws of physics. Have you ever dreamed of changing one of the laws? And if you could change one of them, which one will you change?
That's a difficult question. I hope there will be some new development, some new surprise, obliging people to study new direction. I think the way science is making progress is by revolution. So I hope there will be revolution in quantum mechanics or perhaps in chemistry, in biology, in astrophysics, and this is...
But if you change one of the laws, we will not be here discussing, no?
Yeah, sure.
So the laws,
No, I like
we are the consequence of a perfect.
I like very much physics, of course, because
But which law is the one you will change? Which law? Gravitation, electromagnetism, weak interaction, strong force?
oh, I think probably the question of unification of interaction. You know, there are still a lot of things which are not understood, and as Jocelyn mentioned also, the problem of dark energy and dark matter is something which is really fascinating, and which is really putting very important question. Why we don't see this matter? Why we don't see this energy?
Martin?
Well, I would like to get rid of the uncertainty principle.
Quantum mechanics you would like to change.
Well, maybe, there's has been in the past a lot of argument about, Einstein never liked God playing dice and such, and boom, and other people tried to find hidden variables which would somehow make the world deterministic. I don't know whether physicists worry about that anymore, but it would sort of be nice to be able to have a deterministic world. Of course, a deterministic world doesn't mean that you can, in principle, you would predict the future from what you know now. In practice, very small changes would give you an uncertainty, errors and such in measurement that you could never predict the future for 1,000,000 years. But still, if I had a choice, I'd like to get rid of that.
And you?
I like mountains and hills, and I would change physics so that it was easier for me to walk uphill.
Gravitation.
Not you, just me.
No lo hemos dicho, pero Telefónica ha querido premiar esta pregunta por su ingenio, creatividad y por intentar atrapar la parte más humana de la mente de las personas. Ahora vamos a seguir un poco con las preguntas del sorteo y vamos a dejar los siguientes dos premios para un poquito más adelante. Vamos a ir a por unas preguntas generales. La número 71 es del Colegio Bizkaia.
¿Puedo hacer un comentario? Lineker decía que el fútbol es un deporte que juegan muchas personas y siempre gana Alemania. Pues esto es un sorteo en que hay muchos nombres y siempre sale Jocelyn B.
Por favor, sí.
So Oxford is one of the leading universities in Britain. It takes overseas students as well as British students, so it could be that some of you would be applying to come. How much you have to pay depends on Brexit, however. They look for somebody who is really interested in their subject, but also somebody who has character, personality, people who have slightly different interests, people who will, because of their background, add to the life of the university and the life of the college. And we are also watching very carefully that we take enough women students, that we take enough students from other than white ethnic backgrounds. backgrounds, black and minority ethnic. So if you say you're Basque, you start with an advantage. But you have to have good English.
Okay, perfect.
Laurogeita bigarren galdera, Abadiño zentrotik.
Okay, that's very good.
Bai?
Excuse me. ¿Qué pasa? Calma, calma. If people from other planets or universes will invite us, why? Why they will be interested in inviting us?
Extraterrestre?
Eh?
Extraterrestre. I didn't understand what you mentioned.
Because if people from
From the outside world?
yeah, will invite us, what do you think will be the reason for wanting to invite us? Or you? Well, maybe you thought we were inviting us with the pulsars, no?
Yes. It's actually a question that could become quite relevant because we are finding more stars with planets, and we are finding some of those planets are within the habitable zone where the water would be liquid. So they are places where there could be life. And I believe one of the things humanity has to start thinking about is what we do if we think there is life on one of those planets. Do we assume they are friendly? Do we make ourselves known to them? Do they know about us already? Are they coming to invade? How are we going to approach them? Are they enemies? Are they sociological specimens? Do we study them? Do we put them in a zoo? Do we eat them? The Americans will want to send in the GIs to bring them democracy, but that's not so easy. Why might they want to invade us? Well, of course, it's because of the brain power of our women. That's why.
Maybe that will scare them.
Scare them, yes.
I mean, actually, for a long time, there has been a project, which is still going on, where we send out radiation into space with very simple signals, maybe a few dots and then nothing and a few dots, in the hope that there will be somebody at one of these planets where there may be life, and that they will understand that it's a signal rather than all these various things that Dame Bell has found in space and other people, and that they will want to communicate with us. Now, whether these people, if they exist, will be more advanced or less advanced, whether they will regard us as a food source, maybe they're running out of food, maybe their Earth is being, their equivalent of the Earth is being destroyed the way we are destroying our Earth, and so they may be looking for another place where they can live. I mean, there are many things that might be going on in their minds if they exist. They could be made up they don't have to be made up of carbon, nitrogen, oxygen the way we are. There might be other civilizations, and there are scientists on Earth actually who are trying, for example, to replace the nucleic acids made up of entirely different atoms and seeing whether they can store information in them. So it's actually an active field, not only in the movies, but also in reality, where people are trying to understand the possibilities of other life forms and how they might interact with us if they exist.
You know, I think that it is probable that there are many, many different organizations of life. And living organisms probably are completely different from one word to another one. So I think it would be very difficult to communicate, except perhaps by scientific technique, by some sort of computing algorithm. But I think that of course is a fascinating question, but already we should think what could be a different organization of class, of brain. That's not clear, not easy to answer.
Okay. Hurrengo galdera biografiko bat egingo dugu. 23. galdera. Buruz dakizkizu edo? Zenbakiak? Bueno, denei zuzendutako galdera bada. Uribarritik.
¿Pensabas que ibas a llegar hasta aquí?
¿Hasta dónde? Hasta el nivel que han llegado. Did you think that you were going to reach, to achieve so many things? When you were younger, did you think you were going to be a Nobel Prize? Did you think you were going to reach up the level that you have reached?
No, I mean, I didn't really think about it. I just was always, when I was working, I was excited about what I was doing. I was, I was learning new things. And, at each stage in life, I found something more complex to study. And, you don't sort of, there are some people who live for getting a Nobel Prize and are very disappointed when they don't get it. But I was just excited about what I was doing and didn't really think about that I would come to Sebastian under the present conditions. I came here way before the Nobel Prize. I came to work in Arzak's kitchen, which I found was very exciting for me. So life has many elements, but the important thing is that, and this has come up before, that whatever you're doing, there are two elements. One, that you're excited about what you're doing, and that the rest of the world thinks what you're doing is worthwhile enough so that they're willing to pay you for doing it. And being a university professor really combines these two in a wonderful way, that you're paid to do what you would most like to do, teach and learn by research. So it's a great life, and I hope some of you will end up in it, maybe stimulated by what's going on here today.
Did you think that your career was going to be like the one you have achieved?
No, when I think that depends on the people you meet in your career. When I was young, my parents were dreaming that I would become a doctor. Of course, because doctor was a prestigious career at that time. And then when I went to Economan, I met outstanding people like Kastler, I showed you just before. And the way that you are going in life depends on the personalities which you meet in your studies. If you have outstanding people who can stimulate you, then it's clear that you go ahead and you try to do what they do and to imitate them. But at the beginning, you don't know, of course. I don't think, at least for me, you have no plans of career. It depends on the people you meet and the interests that they're able to rise in you.
But you never thought you were going to get the Nobel Prize. You told me you had to go back home to change because you never expected that you were going to get the Nobel Prize. No?
No, I think it would be a mistake to think of the Nobel Prize. Because there are so many people who could have obtained it and we didn't get it. It's ridiculous. Of course, it's something fantastic, but it's not the whole story. The important thing is that what you have done, what you have brought to the knowledge.
Thank you.
My goal in life has been to make good use of the talents that I have been given, ideally to use them in the service of other people and the world, and never to give up, to keep trying, keep working. And that takes you where it takes you. That's not in your control.
Very good.
Beste galdera biografiko batekin jungo gara. 11. Uribarritik.
Es fácil apreciar que llegar a donde habéis llegado y todo lo que habéis aportado a la ciencia os ha costado muchísimas horas de duro trabajo. Pero, ¿alguna vez habéis pensado qué es lo que habéis sacrificado de vuestras vidas? Y si es así, ¿os arrepentís de ello?
It is easy to appreciate all you have done, all you have brought to science, given to science, and it's obvious that that has cost you a lot of hours of very hard work. Sometimes have you thought that what have you lost in your life because of that? Are you sorry?
I think the short answer is no. And
That's a very good answer.
I mean, really that, I was able, as has come up before, to do so many different things in my life with my family. You discover new things, you do cooking, you do photography, you do all these different things. So I think I've been very lucky that I've been able to live a full life. I mean, there are some, the imaginary scientist who's all day in the laboratory and all night in the laboratory and doesn't do anything else. That's not the way my life went. But I think in at many stages in my life, it was luck because I met a certain person, I was given access to a certain computer, and it just worked out in such a way that I'm very happy with it. And probably, although I'm now 86 years old, I'm still excited about what I'm doing, as I mentioned earlier. So, I mean, my life could have been different, and I think it still could have been happy. But it went in a certain way, and I was happy with it, and I don't think I really missed anything that I can sort of focus on. At one point, I thought I was going to be a photographer, but then I decided, well, there wasn't enough intellectual challenge in taking photographs. I've been told since then by professional photographers, well, it's really very complex, and you can have as much of an intellectual challenge in taking pictures as in doing science. But to me, it wasn't like that, and so I've been happy the way things turned out.
Claude?
Personally, I don't think you should worry about sacrificing your life when you do science. If you do science, it's because you are interested in science. You are not sacrificing your life. Of course, you don't do science like an ordinary job. It's because you are passionate. Science is a question of passion. You have to be passionate about what you do. And of course, when you are interested about what you do, you can do great things. You can also, in your neighborhood, stimulate people also to do the same thing.
Jocelyn.
When I had a young child, I was made to feel very guilty about working. I should have been at home looking after the child, because it was said that if a mother worked, the children were delinquent. How many of your mothers work? And how many of you are delinquent? Yeah, there's always one or two in the back row. I think that was false, being made to feel that. But it was quite strong at the time, and it was difficult. I think that's the main thing that has been an issue for me, and it's actually to do with changing society and the way we think about the role of women and mothers.
Vamos a desvelar cuál es la segunda pregunta seleccionada por Telefónica para entregar uno de sus premios. Javier, por favor, si puedes acompañarme. Es la pregunta número 118 y ha sido premiada por cuestionar las ideas preconcebidas del mundo que nos rodea, ya que así es como una mente científica hace avanzar el conocimiento. La pregunta es de Vera Garmendia y le vamos a pedir que suba aquí con nosotros. Sí, es la pregunta. Espera, vamos a ponerla en pantalla, por favor. Ahora.
Vale. Nik uste nuen lasertiek edo behintzat berotu egiten zutela. Hau da, normalean laserrak beroarekin erlazionatuta zeudela uste nuen. Orduan, nola egin zenuten atomoen temperatura hainbeste edo txikitzeko?
I always thought that laser beams could heat, but normally we relate lasers with heat. Then, how could you do in order to lower the temperature so much?
Okay.
Yeah.
Okay. You know, laser light is composed of photons coming all in the same direction. And when an atom absorbs a photon, it gains the energy of the photon, of course, because it goes from one level to another higher level, and it gains also the momentum of the photon, which is h nu over c, where h is the Planck constant, nu the frequency of the light, and c is the velocity of light. So an atom which is submitted to a beam of photons absorbs this momentum, and the change of momentum per unit time is what is called in physics the force. So an atom in a laser beam undergoes the radiation pressure, and if it goes ahead the laser beam, it is slowed down. And if you excite the atom from all with different laser beams, then you can reduce the velocity of the atom by radiation pressure, and the temperature in physics is related to the kinetic energy of the atom, and then you lower the kinetic energy. And there have been many developments allowing one now to reach temperature in the range of a nanokelvin. Nanokelvin is 10 to the minus 9 Kelvin, whereas the room temperature is 300 Kelvin. So with laser cooling, now you cool atoms to temperatures which are 300 billion times lower than room temperature. So they're extremely cold. And then you have a lot of new phenomena which appear, because in physics, the de Broglie wavelength of the wave associated with each particle is inversely proportional to the velocity. If you reduce the velocity, you increase the de Broglie wavelength, and then you get atomic systems where the wave nature of matter becomes extremely important. And you can get new systems, for example, called Bose-Einstein condensate, where you have a macroscopic number of atoms with a huge macroscopic matter wave, which have fascinating properties. Very good.
Pues vamos a seguir con la ronda de preguntas. Vamos a seguir con alguna científico-técnica. La pregunta 143 del Colegio Urdaneta. ¿Algún estudiante aquí, en casi primera fila? Ese micrófono a Karplus y eso.
Ya que los átomos no son homogéneos, ¿qué frecuencia de láser permitirá frenar los rápidos sin empujar a los lentos debido al desplazamiento Doppler?
Since the atoms are not homogeneous, which frequency of laser will allow to stop the fast ones without pushing the slow ones due to the Doppler shift?
You know, the idea of laser cooling, the first one, which was put forward, is actually using Doppler effect. If you take an atom with two counter-propagating laser beams with the same intensity and with the same frequency below the atomic frequency, you know, if the atom between the two laser beams goes towards this direction, the frequency of this beam will appear higher, so closer from resonance, and the frequency of the co-propagating beam will appear lower, so farther from resonance. So you will have a disequilibrium between the two forces due to the Doppler effect, and which gives you to radiation pressure, which is opposite to the velocity. So now the laser configuration produces some sort of a viscous medium, because the velocity is damped, and this is the way you are damping atoms.
Beste galdera zientifiko-tekniko bat aukeratuko dugu. 157. galdera. Arratiatik antxe erdiedean.
Okay.
Saiakera zientifiko baten mundua testuan ipini dezake?
It's possible that a scientific experiment will put the world at risk. Maybe third.
Well, I didn't understand your translation.
The translation is it possible that a scientific experiment that somebody does can put the whole world in danger, at risk? Some people said before with the LHC that... What is the answer? No.
You know, I think you cannot answer this question. Take, for example, the nuclear energy. That was a very important discovery, nuclear fission. Of course, Copert Meyer, a lot of famous people. Of course, from this discovery, you have made the atomic bomb, which is a terrible thing. But on the other hand, with nuclear energy, you can produce energy and you can save coal and you can solve energy problems. So I think science, when science progress, it should be accompanied by ethical problems. Scientists should be aware of the dangers of what they found, and there will be some ethical organization trying to control the bad effect of science. That means education. You need education. When we are saying this morning, you need to form citizens who have a scientific formation and which are able to take societal decisions which are worthwhile.
Well, I think many scientific experiments recently have put the world at risk in some sense. That it's really partly what you say, that we now have hydrogen bombs, and the chance of releasing a hydrogen bomb by mistake, with North Korea or other countries, that something. I mean, there's this question of the red telephone. That if by mistake the US releases a missile with a hydrogen bomb on it and wants to tell the Russian premier that this was a mistake, the question is, can he really convince the Russian premier? Or will the Russian premier send out a hydrogen bomb which will completely destroy New York? And of course, it may not necessarily destroy the whole world, but it'll be very close to it. So the fact that science has made available to the human race these very great powers, which you mentioned, also means that we are in a dangerous situation. And not to mix politics, but what's going on in the United States. If Trump became president and he knows nothing about any of these things, who knows what would happen to the world? So one really worries about it.
I agree with what both my colleagues have said. I just want to add the rider that it is important that the experts, the scientists, are listened to and not ignored. And one of the most disturbing trends in Western society at the moment, we see it in the US, we've seen it in Britain, who needs experts? Politicians are okay. We need the experts alongside the politicians.
And maybe one remark following on that is, if you take the United States Congress, it has two people who know something about science, and they're making they just happen to have been elected, and all the rest know nothing about science. And so to leave up to this body to deliberate about something like that has a scientific basis is really dangerous, and I think that's sort of what you were driving at, but in the United States at the moment, that's the situation.
I think that politicians should have a better scientific background. Unfortunately, this is not the case. Because, managing science, giving money for research needs a knowledge of science. And unfortunately, most of the political men or women are not experts in science, and they don't realize the benefits and the dangers of science.
It comes to my mind the famous sentence by Churchill, no? Scientists should be on top, but not on top.
Yeah.
Should be at the disposition of the politicians, but not to have any say that on top, but not on top.
Yeah. And we are supposedly here exciting you about science, but I think it would be nice if some of you who are excited about science maybe also went into politics, that the world would become a safer place where all the power that we now have is being judged by people who know something about it.
Yeah.
Very good.
Ozen urrengoarekin. 161. Urretxuzu gomarragatik. Anatzekaldean dago ikasle.
What do you think about the first quantum computing and the influence that it will have in the future?
Well, I mean, at the moment, quantum computing is a dream, and people so far have made programs that imitate quantum computers, but in terms of how, I mean, the dream is that quantum computers will be 1,000 times as fast as the present computers. But at the moment, a lot of science is being developed in trying to create quantum computers that actually work. But at the moment, there aren't any quantum computers that work better than programs that imitate them, essentially. So I think as one says in English, the jury is still out whether they will actually come into existence and be able to do what the people who work on them, and some very good scientists work on them. And it's often true that when somebody has this dream, that they will do a lot of interesting science to try to get there, even if they don't get there. So it's certainly a stimulus for science to try to make quantum computers. But from what I know, and it's really as an amateur, I have a colleague at Harvard who is from Mexico, actually, who is very much interested in that, and we discuss it. But so far, it's a dream that is leading to new science, but per se doesn't exist yet.
I think that quantum computer is a very great challenge, and a lot of people are thinking about it. And a lot of governments are putting money for doing quantum computer. But it's not easy. It uses separate quantum properties of systems, and when you have many, many atoms and many components, then you have a lot of effects which destroy what you want to do. So it's not easy. I don't think we will have a quantum computer in 1 or 2 or 3 years. It will be a long-term job. And I think also I would like to make a remark concerning this kind of program. You know, generally there are programs towards a specific goal, and you get money for a given objective. I think it's a mistake. It's a mistake because the most important discoveries are not done in that way. What I hope is that in the research for quantum computer, you will find some side effects which are more interesting and which give you a different road to improve your communication ability. So, yes, quantum computer is important. It is not easy to do, and I hope that some new idea will come, is completely different, and will allow to find new interesting things. For example, the laser was not planned. It appeared as a result of fundamental studies. I think that politicians should support fundamental research, not applied research, because the most important discovery comes from fundamental research. Cannot be planned in advance.
Ahora que el Parlamento Español tiene mucho tiempo libre porque están en funciones durante un año, igual le podíamos invitar a Claude que les explicase un poco estas ideas, no nos vendría mal a todos. I just said, now that the Spanish Parliament is discussing for over a year without reaching an agreement to appoint a government, but maybe it will be great if you could give a speech to the Spanish politicians. It will be good for all. Yes, but I believe the laser was called a solution, so an answer searching for a problem, no?
Yes.
Okay, then, you have, no?
No.
A woman can be past this way. How can you?
I think it is important for a scientist to be able to say, I don't know, rather than pretending you know and speaking with great authority and speaking total rubbish.
Okay. Now I will ask one question, each of you, but if the others want to go, also they can complement, but not necessarily. First, for Jocelyn, are you a person?
No.
Oh, no?
We are going to announce the prize
I apologize.
first. And we
First,
still
we announce another
we
prize.
still have 10 minutes more for some more questions, and we will leave those ones for the end.
You see?
If you don't mind.
She tells me I should ask this question,
And then she tells you
and
not
now
to.
she tells me to wait, and of course she's right, she's the leader.
Sorry. So, Javier, if you want, vamos a anunciar cuál ha sido la tercera pregunta seleccionada por Telefónica. Hirugarren ez da azken saria zein izan den ezagutuko dugu. Saria 159. galderari eman nahi dio Telefonikak. La tercera pregunta seleccionada ha sido de Amaya Marchán, del Centro Koldo Michelena. Amaya, por favor. Telefónica. Telefónica ha querido premiar a esta pregunta por su imaginación, ambición e innovación ante la búsqueda de nuevos horizontes en la investigación y la ciencia.
Gutxien dagoen tokiraino doa. Zer gertatuko da unibertso osoko energia orekan dagoenean?
Everything goes from from places where there is high energy to the place where there is low energy, to minimize the energy. What will happen when the total energy of the universe is in equilibrium?
The total energy
of the universe is in equilibrium.
Shall I start?
Yeah.
Okay. So the future of the universe is black. What is happening is that the stars are burning, doing nuclear reactions with hydrogen to make the heavier elements, make the nuclei of the heavier elements, which is great. There's more gold in the universe, but less hydrogen. And the problem with that is that it is hydrogen that starts a new star shining, because it is a hydrogen fusion reaction that is the first thing a star does. So in the distant future, the old stars will go out. There will be lots of gold, but new stars will not light, because there is not enough hydrogen around. That's a bit of the answer that is consistent with what is behind your question. But there is another factor, and I wonder if this is going to change our thinking in a bigger way. The universe is expanding, always has been. It is currently expanding faster and faster and faster. And there will become an interesting situation. You have been told that nothing can go faster than the speed of light. Heard that? Yes. Actually, we need to sharpen the statement. Nothing can go through space faster than the speed of light. but space itself can go faster than the speed of light. And probably what is happening in the distant universe, and will happen more and more, is that space is expanding faster than the speed of light. So we don't see the galaxies embedded in that distant space. And as the universe ages, more and more stuff is beyond that horizon. So our sky will become emptier, fewer things in it, and the stars will have gone out also, which means there are just black holes having fun, as black holes do.
If you want to answer the question, excuse me.
Yeah, I was just going to add to the answer from a different viewpoint, which is that as living beings are actually made up in such a way that we make more and more complex systems because we are using energy from the universe, which, from today and probably for hundreds of thousands of years or even longer, will not have been exhausted. And the whole point of a living being is that it can create complexity, which is reducing essentially the entropy of the system. So it's violating, in some sense, it quotes the second law. It's not actually violating it because it uses the energy to do that. But that's why we've been able to go from single cells to human beings like us up here with very complicated brains and such. So you can take sort of the cosmic viewpoint on the left here, and if you like, the human viewpoint on the right here, that you have a different perspective on what happens in terms of development, increase or decrease of entropy and such. So I think that's a little, yeah.
I agree, of course, with Jocelyn when she said that the lifetime of stars is finite. The future of stars is disappearing when they exhaust their nuclear fuel. And of course, when you use the universe as a whole, the energy is going away as radiation, and it collapses. But I'd like to answer the question in different perspective, in the way of, in a laboratory, where you have a finite system composed of two parts, a subsystem and the surrounding, and then the subsystem can be interacting with the surrounding, which is some sort of a reservoir, which provides energy and which prevents the small system to decay. And for example, the laser itself is a very nice example of such a system. You have an ensemble of atoms which are excited by a pumping thermostat, which maintains them excited. And then they can emit light in a coherent way. In other words, you transform disordered energy of a reservoir to ordered energy of a laser beam. So depending the system you consider, the question of where is the energy going has different answers.
Bueno, tenemos unos minutos más para unas últimas preguntas. Vamos a seguir con una general. Laurogeita hirugarren galdera. Almen Arizmendi ikastolatik. ikaslea hor da.
Zuen esperimentuak aurrera eramateko leizbait seguru arriskuan jarri ahal duzue.
In order to do your experiments, has your life or yourself been in danger sometime? In doing your experiments, have you been in danger yourself sometime? You are a theoretician, so you are in a theoretical danger, so there's no problem.
Well, yes, I mean, well, we're all, in some ways, well, I use computers. I mean, the only real experiments I do in chemistry is in the kitchen, and I don't think I've ever endangered anybody in my experiments in the kitchen, but otherwise, I mean, people say that you have to be careful about computers and that they radiate, but I think the real danger is negligible. And though it was interesting to hear, I don't know whether it was last night when you gave your talk in Bell about microwave ovens, that you had to be a little bit careful, that you shouldn't open them, but you should turn them off first, which I will do from now on when I do my cooking.
Yes. Yeah, just to explain that context, I work in radio astronomy. We are picking up very faint radio signals from space. And if there is a microwave oven nearby, it's okay if the door is shut. But if you stop a microwave oven by opening the door for a millisecond, maybe a microsecond, there is a blast of microwaves comes out the door, which is not good for radio telescopes and is not good for you. So please stop the microwave oven by pressing the stop button. I have worked in branches of astronomy where we used high voltages, and that always needs a bit of care, particularly when you have a prototype experiment where it is not perhaps quite as safe as the ultimate final version of the experiment. But probably the biggest danger has been flying in aeroplanes to go to telescopes in Hawaii and Australia and things like that.
Arogeita zortzigarrena. San Nikolas ikastolatik.
Zein da zientzia ikasteko ikertzaile nazionali emango zituen erabakoak erantzitarreko gogoetan aurrera jarrizko?
What will be the advice that you will give to a young researcher in those days in which nothing happens, no answer comes from the experiments, to continue doing, not to give up? You mean when nothing happens? When he is not good, he or she is getting no results?
Well, I think you have to sort of have a compromise between what you believe that you're doing is really something good and important to do, and maybe it doesn't work today, but it'll work tomorrow. On the other hand, you have to have perspective on it, and if it just doesn't work, maybe go to your research advisor and ask him, what does he think? Am I on the wrong road or such? But I think the only thing I really want to say is that you shouldn't give up too easily. Because if you're trying something new and difficult, it may not work out the first or the 10th or maybe the 50th time that you do it.
No. It often happens that an experiment is not working as you expect, of course. Then what you have to do, an experiment depends on many parameters. then you have to control every parameter, try to change it, and to see if the result is changing. And if the result is changing after a very careful examination, I think before drawing conclusions, the experiment should be repeated elsewhere in a different condition. And if the disagreement is still there, that means that perhaps something important is behind. And then you have to think about it and try to imagine other schemes for explaining what you're observing. Perhaps it's just trivial, perhaps it's very important.
This is something that happens to all of us, and it's something you have to accept as part of doing research. If you really feel you are making no progress, you are not even learning anything new about repeating the experiment, well, I would go do something else for a little bit. Go for a walk, go for a swim, take a day off. Maybe when you come back, you have some fresh ideas, or you can see what is wrong or missing. But maybe even that doesn't work, in which case perhaps you set that experiment aside and you try coming at the problem from a different angle, do a different kind of experiment. As the others have said, there is probably some message for you if the experiment will not work and will not work and will not work. So finding what that message is also useful.
...2016ko topaketari amaiera emateko azken txampan sartu gera, eta Pedro Miguel Etxenikeri utziko diot ekitaldiari amaiera ematen, baina gogorarazi nahi dizuet, amaitzen dugunean denok Bizkaiaretoko jolean elkartuko garela familia argazki bat ateratzeko ados. Gero mesedez jarraitu azafaten argibideak eta argazki aterako dugu kanpoan. Eskerrik asko.
Para terminar, voy a hacer una pregunta a cada uno. Elegiré yo la pregunta. Si el que la ha hecho sabe que es la suya, la puede levantarse y hacer, les diré el número. Si no, la haré yo. Y después haremos un breve resumen y nos vamos, que ya tenemos... Porque cuando suelen decir que solo hay una cosa más dura que un discurso a los postres, que se llama after dinner speech, que es un discurso a los entremeses. Entonces vosotros estáis con ganas de comer. Bueno, entonces la primera pregunta es la 81. Si el que la ha hecho la hace, bien, si no la hago yo. Porque no sé si con el ordenador puede salir si se elige la 81. Entonces hago... ¿Así? ¿La 81 estás ahí? Vale, perfecto, venga. Para Jocelyn Bell.
The microphone is not working.
Microphone not working. Okay.
It's all right, there's a microphone coming.
Okay, the question, God, do you believe in God?
Yes. So, am I religious? Do I believe in God? Yes, I go to church often and have been an elder in my church. I belong to a very small church called Quakers, and in Quakers, you are not told what you have to believe. You are told you must work it out for yourself. And as you go through life and get more experience, you are expected to change what you believe. It is quite like being a research scientist. You, as a research scientist, you collect data, you formulate a picture of what the star is like, you get more data, you change the star. So for me as a Quaker, there is no problem. But if I belonged to a church which told me what I had to believe, I probably would have a problem.
La 122 para Karplus. 122, ¿quién está? Si no, la hago yo. ¿Ok? La hago yo. What is today the relationship between science and technology? Science and technology. What is the relationship?
Well, I think there's a very close relationship that most technology of today is based on science of some years ago. And I think it's a mistake, I mean, this has come up a little bit also before, when governments that support science want you to say, you know, what good is this going to do? Because the most important new science, you have no idea whether it's going to do any good or not. But if you look at the history, like the laser which was mentioned wasn't you know, some technological invention. It just was, Charlie Towns was doing certain experiments, and out of that came the laser, which now is tremendously important in much of industry. So I would say that technology is the child of science, but it shouldn't govern science.
To Claude, do you think that in science, working hard is enough, or there are other factors such as creativity, luck, necessary?
Obviously, there are luck, because when you choose a subject, a topic to study, you have the luck to choose a good topic. But I don't think just luck. You have to work hard, and you have to discuss and to exchange ideas. This is what I think international relations are very important. I think science is international, and having discussion between scientists coming from different cultures, different countries, is very useful for developing new ideas, new approach, new way of understanding what you are doing.
Oh, thank you. Now I'm going to make the summary in Spanish. Shall we try if they work? Could you try?
Mine doesn't work.
No, then I will do it in English then, okay? Doesn't work? ¿Funciona la traducción? ¿Funciona, Claude?
Number 2?
Number 3. ¿Funciona?
Number 4.
¿Funciona? ¿Funciona? ¿Traducción? ¿Le puede traducir? ¿Funciona? ¿Funciona? ¿No? ¿No?
Am I supposed to hear a translation?
Sí, ¿puede traducirle, por favor, el traductor para ver si funciona? ¿Funciona?
Okay.
¿Funciona? ¿Funciona? Okay, then I prefer to make... Anyway, I will do it in English. I will do it in English. Just to summarize some ideas. ¿Funciona? Good? Okay, in Spanish. Then if no, I translate you in the car, what I say when we go back home. Bueno, un resumen muy breve, como es tradicional en estos encuentros, ver algunas ideas que han salido, ¿no? Ha salido aquí, se ha visto muy claro que la ciencia tiene grandes componentes de creatividad y de imaginación, por lo tanto no se puede aprender simplemente como método, sino solo se puede aprender a hacer ciencia haciéndola junto a los que la hacen bien. Y por eso es importante ir a los buenos sitios, a esos centros que son linajes científicos, muy bonitamente expresado por Claude, cuando ha dicho que él es alumno de Kastler y profesor de Haros. Los linajes, instituciones de excelencia. Y por eso es importante que en nuestro país busquemos esas instituciones de excelencia. Tenemos que tener algunos internacionalmente competitivas y donde se aprenda la forma de hacer ciencia, ¿no? De lo que yo he visto aquí, me ha parecido que más importante que intentar anticipar el futuro, más importante que intentar anticipar el futuro, no vamos a predecir qué es lo que va a venir. El futuro ya no es lo que era, como decía el otro. El futuro es inesperado. Es la educación. Contribuir no a adivinar los éxitos del futuro, sino a formar las personas que los lograrán. Educar las personas que serán capaces de crear esas revoluciones, ¿no? Y en el plano familiar ha sido muy bonito oírles hablar de que no hay incompatibilidad con las familias, pero como en todos los demás aspectos de la vida, a unos les va bien, a otros les va mal. Claude ha hablado de armonía y me ha acordado cuando Karplus citaba a Lisa Meitner, de su sobrino, creo que era Lisa Meitner, Otto Fritsch, ¿no? Otto Fritsch era sobrino de Lisa Meitner, y cuando él dijo en un libro que a mí me impresionó, en aquel momento los hombres eran los que trabajaban ahí, Jocelyn dijo que a wife, una mujer, es muy importante para la vida de un físico, porque le puede hacer la vida agradable, siempre y cuando él sea capaz de hacérsela agradable a ella. La armonía de la que decía Claude, ¿no? Y luego, aquí se ha visto, los tres han hablado de conocimiento, pero han hablado también de sabiduría. Y a mí me venía a la cabeza el famoso poema del coro de Eliot. ¿Dónde está la sabiduría que hemos perdido en el conocimiento? ¿Dónde está el conocimiento que hemos perdido en la información? Pero las decisiones del futuro no son cuestiones solo de conocimiento, sino de sabiduría. Y también que investigación no solo es conocimiento, sino es convicciones, decisiones y acciones. Habéis visto también que Nobel y todo, porque Jocelyn no es que sea Nobel, es la estrella Nobel que brilla más en el firmamento de los Nobel, porque es mucho más famosa que si fuese el premio Nobel, porque es el premio Nobel que obviamente debía haber sido. 3 premios Nobel aquí, a muchas preguntas no tenían respuesta. O sea que en la frontera entre lo conocido y lo desconocido, todos somos ignorantes. Esto quiere decir que habéis hecho muy buenas preguntas. Y lo que habéis aprendido aquí es que son personas normales, incluso muy simpáticas, y que además el corolario de estas reuniones siempre es el mismo. Solís entrar asustados y salís ya entusiasmados, y además, si trabajáis como ellos, algunos de vosotros, muchos, podréis ser como ellos. Así pues, gracias a todos, a vosotros, a los profesores y a los